Hello friends, today we will learn the Mathematics 10th Standard Chapter 1 Real Numbers. On to the exercise 1.1. We'll go into the textual exercises. In the exercise 1.1, first question is use Euclid's division algorithm to find the HCF of 900 and 270. Okay, what is Euclid's lemma? It is A equal to BQ plus R, where R is the remainder, Q is the quotient. Okay, Q is the quotient, R is the remainder. Okay, that is nothing but if you take any number, suppose there is any number 24. 24 is nothing but, now if you are dividing it by 3, suppose you are dividing 24 by 3. Okay, 3 8s are 24, 0. Okay, so here how you write this according to Euclid's lemma is 3 into 8 plus 0. This is only Euclid's lemma. Okay, so this is how we go about it. Here the two numbers here are 900 and 270. How will you go about it is see which is the bigger number. Which one is the bigger number? 900 is the bigger number. So what you will do is divide the bigger number by the smaller number. So when you divide 900 by 270, you get 900 equal to 270 into 3 and your remainder will be 90. Okay, then next what you should do is you should take this number down, 270 here. Okay, you take the 270 here and you divide it by the remainder, whatever is the remainder, with that you will divide. Okay, 270 equal to 90 into 3 plus 0. So as soon as you get the remainder 0, okay, as soon as you get the remainder 0, you can conclude that this number is our HCF. Whichever we are multiplying with, that number is our HCF. Okay, that is 900 equal to 270 into 3 plus 90. So nextly what you do, 270 equal to, you will take this number, this remainder, okay, 90 into 3 plus 0. Whenever you get the number 0, this one is our HCF. Okay, our HCF equal to 90. Okay, then we go on to the next one, 196 and 38220, 38,220. How do we go about it? Same way, bigger number divided by smaller number. When you divide 38220 by 196, you get it as 196 into 195 plus 0. Now in the first go itself you got the number 0, therefore our 196 is our HCF. Okay, next 1651 and 2032. Among these which one is the bigger one? Yes, 2032 is the bigger one. So 2032 divided by 1651, what will you get? 2032 equal to 1651 into 1 plus 381. Here the remainder is not 0. So what will you do? You will take this number down here and divide it by the remainder. 1651 equal to 381. Here remainder is 381. So here we are dividing by the remainder. 1651 equal to 381 into 4 plus 127. Again we are getting a remainder. It is not 0. So we have to go again. Okay, so what will you do? This number goes here. 381 equal to, what is our remainder in the previous step? 127. When you divide 381 by 127, you get 127 into 3 plus 0. Yes, we got the 0. Therefore, this 127 is our HCF. Okay, we move on to the second question. Use Euclid division lemma to show that any positive odd integer, odd numbers, what are all the odd numbers? 1, 3, 5, 7, 9. These are all odd numbers. Whichever is not divisible by 2 is called an odd number. Okay, so whenever a number ends with 1, 3, 5, 7, 9, it is an odd number. Okay, so what is our task here is we have to show that any positive odd integer is in the form of 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. Okay, so let us see how we are doing it. So we will assume a to be a odd positive integer. Okay, let a be a odd positive integer. So we will apply the Euclid's division lemma. So what will you get? A is nothing but any number. A equal to, so here according to the sum it should be divided by 6. So our b equal to 6. Okay, 6 into q plus r. Okay, r can be, what would be the remainder? The r can be either, r may be either 0 or 1 or 2 or 3 or 4 or 5. It cannot be 6. 6 ones are 6. So r can be either 0, 1, 2, 3, 4 or 5. Okay, so here goes the explanation. If a can be 6q, so if the remainder is 0, so what will it be? A equal to 6q plus 0, that is nothing but 6q. Okay, 6q plus 1 or 6q plus 2 or 6q plus 3 or 6q plus 4 or 6q plus 5, where q is the quotient. But a is taken as odd number. When it is an odd number, it should end with 1, 3, 5, 7 or 9. But here if we see here, in this step we have 6q plus 2. 6q plus 2 is nothing but, if you divide it by 2 it will be divisible, right? 2 into 3q plus 1. So this is an even number, so it cannot be an odd number. The same way if you take 6q plus 4, that is again divisible by 2. 6q plus 4 equal to 2 into 3q plus 2. This is also divisible by 2. Therefore, it is not an odd number. It is even number. So, we cannot consider 6q plus 2. We cannot consider 6q plus 4. Okay. So, the same way 6q also. 6q, how would we write? 2 into 3q. This is also divisible by 2. This is also not an odd number. So, excluding these three, apart from these three, we have to see the other ones, which are nothing but 6q plus 1, 6q plus 3 and 6q plus 5. Okay, so those are the odd integers. Okay, so any odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. We go to the next question. Okay, use Euclid's division lemma to show that the square of any positive integer, here there is no condition, even odd, any positive integer is of the form, here what it is square of, okay, is of the form 3p or 3p plus 1. So what we will do is, we will assume any number, let a be the square of an integer. Apply Euclid's division lemma with a and b equal to 3, because here it is written in multiple of 3. So b equal to 3. Since r will be less than equal to 0, that is r can either be 0 or 1 or 2, because 3 is the divisor. Okay, so here what will you do? A equal to 3q or a equal to 3q plus 1 or a equal to 3q plus 2. This is one way. Another way of the same thing is, let us take a is any positive integer. A is a positive integer. According to Euclid's lemma, a equal to bq plus r. So what is our condition here? We should find the square. Okay, a square. If it is 3q, okay, so that is nothing but 3q square, which is nothing but 9q square. Can you write in terms of 3? Yes, of course. This is nothing but 3 into 3q square. So this is a multiple of 3. So if you take this as p or m or k or j, anything, it is in the form of 3p or 3s, 3t. If you substitute this with any variable, you can use. So this is a multiple of 3. So it is in the form 3p. Okay. So let us take the next one. That is, one is 3q. Next one is 3q plus 1. If you say a square equal to 3q plus 1 whole square. Here, whenever there is whole square, you should use a plus b whole square formula. A plus b whole square equal to a square plus 2ab plus b square. What is our a? A is 3q, b is 1. So 3q plus 1 whole square will give you 3q plus 1 whole square equal to 3q whole square. Okay, 2 into 3q into 1, 2ab plus 1 square. 3q square, remember this is square for 3 also. 3 square, q square. 3 square again, remember it is not 6. 3 square is nothing but 3 into 3, which is nothing but 9q square plus 2 3s are 6. 6 into q, 6q into 1, the same thing, 6q plus 1 square also, remember, don't write 1 square is 2. 1 square is 1 into 1, 1. Okay, so 9q square plus 6q plus 1. So if you write in terms of 3, how would you go about it? 3 into 9 is multiple of 3. 3 into 3q square. 6 is also multiple of 3. 2q. 1 is not so. So we can put it outside. So here if you take q square plus 2q as any variable, as we have taken here p, I will use the same thing. 3p plus 1. So first one is in the form 3p. Second one is in the form 3p plus 1. Okay. Now next step. Next is 3q plus 2 whole square. Same method. 3q plus 2 whole square. What do we get? 9q whole square plus 12q plus 4. So here what we are doing is 9q square plus 12q. This 4 we are writing as 3 plus 1. So that this whole thing we can write in terms of 3. If you write in terms of 3, what would you get? 3 into 3q square plus 4q plus 1. Okay, so this is also in the form of 3p plus 1. What is your p here? P is nothing but 3q square plus 4q plus 1. So it is either in the form of 3p here, yeah, or in the form of 3p plus 1, again 3p plus 1. So 3p or 3p plus 1. So this is proved. Okay, we go on to the next question. Fourth question. Use Euclid's division lemma to show that the cube, now we said square, now we are telling about cube. Okay, so the first method is here and the second method is also here. So we will go with the second method, which is very easy to understand. What is our Euclid's lemma? A equal to bq plus r. Okay, now we are taking b equal to 9 because in the question it is given 9m plus 1, 9m plus 8. So our 9 is the b. Okay, and then let a be any positive integer. So we can take as a equal to 9m plus r. What can r be? R can either be 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. So these are all the possibilities. Okay, so if a equal to bq plus r, okay, so how will you write a equal to 9q plus r? Okay, so now if you take a cube equal to, firstly, if 9q plus 0, a cube is nothing but 9q whole cube, which is in terms of 9, that is 9 into q square, that is in the form of 9m. It need not necessarily use m, you can write any variable. This is to show that 9 into something. Okay, so if it is 9q plus 1, a cube equal to 9q plus 1 whole cube, sorry, here it is whole cube. Okay, so 9q into 9q into 9q. Okay, so this is in the terms of 9. Here if it is 9q plus 1, so how will you go about it? 9q plus 1 whole cube. Okay, so that will come like this, 9q plus r whole cube. So for whole thing we will take one general common thing into the final division. Okay, so a cube is equal to 9q plus r whole cube. If you take a plus b whole cube, what is the formula? A plus b whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. This is our formula. This is in the form of a plus b whole cube. Therefore, we are applying this formula. So, if you take 9q plus r whole cube, you will get the answer a cube. Okay, a cube is nothing but 9q whole cube plus 3 into, what is your a? What is your a? 9q whole square. Remember, full square you should put, don't only put for q. Okay, 3a square. What is your b? B is r. Okay, so we will put the square bracket to avoid confusion. Here also one bracket is there, no? So again 3 into, this also big bracket will put 3 into, what is our a? 9q into, what is our b? R square. Okay, so this again big bracket plus, what is our b? R cube. So we are going to substitute this formula for each r. For here it is r maybe 0, 1 or 2, 3 or 4. That way we are going to substitute that respectively. So ultimately what do we derive at? So here we can see that 9q whole cube equal to 9 cube q cube plus 3 into 9 square q square into r. This is whole square. So it is square for 9 also, q also. Okay, and then plus 3 into 9 into q into r square. Okay, q into r square should come here. Okay, plus r cube. So this will give you. Now if we take everything in terms of 9, because here we are given the task 9m. Okay, so we are going to take in terms of 9. This whole thing. Firstly we will see. Here 9 we take out. What is remaining inside? 9 square. 1 9 came out. So 9 square q cube plus. Here you see 9 square is there. 1 9 we kept outside. So here we will get 1 9 inside. 3 into 9 into q square into r plus 3. Here in this 9 we have kept it out. So 3 into q into r square plus r cube. Okay, so here we will get a cube equal to 9m plus r. Well, that is 9m is this whole thing. They are taking it as m. Okay, that is, it can be any variable. Okay, so a cube equal to 9 into something plus r cube. It is the remainder cube, where m is this one. Okay, so here if we go ahead, so this is our general formula. Okay, so what we have to conclude here is, if r equal to 0, if r equal to 0, so what is the one? Our formula is a cube equal to 9m plus r cube. Okay, if r equal to 0, if r equal to 0, that is, this will give us 9m plus 0 cube, which is nothing but 9m. Okay, if r equal to 1, this will give us 9m plus 1 cube, which is equal to 9m plus 1 cube also. Again remember, don't write 1 cube is 3, 1 cube is 1 only. Okay, if r equal to 2, 9m plus 2 cube, again don't get confused, 2 cube is 8, 9m plus 8. If r equal to 3, what will you do? 9m plus 3 cube. What is our 3 cube? 9m plus 27. This if you write in terms of 9. So how will you write? 9 into m plus 3. Okay, so this is 9 into something. So you can say 9p also. Okay, this is again coming in this 9m form. Okay, and then if you see, if r equal to 4, 9m plus 4 cube. 9m plus 4 cube will give you 9m plus 64. 9m plus 64. So that we are writing as 9m plus 63 plus 1. That is 9 into m plus 7 plus 1. That is coming in terms of again 9m plus 1. Again if for 5, if you do, if 9m plus 125. 125 if you split it, you can get 117 plus 8. So you again get 9 into m plus 117, which will give you 9m plus 8. Okay, so if 6, you'll get r cube equal to 216. If you write in terms of 9, it comes 9m plus 9. R equal to 7, 243. So 243, how you'll write? 9m plus 9 into 27, which is again 9m. 9m means 9 into something. Okay, it is a multiple of 9. So if r equal to 8, 512. A cube equal to 9m plus 9 into 56 plus 8. This will again come in the format 9 into m plus 56 plus 8. So 9m plus 8. So from the above thing we are clear that a cube is either in the form of 9m or 9m plus 1 or 9m plus 8. Okay, so move on to the next one. Show that one and only one out of n plus 2 or n plus 4 is divisible by 3. Okay, so firstly we have to show that n among these three, either n is divisible by 3 or n plus 2 is divisible by 3 or n plus 4 is divisible by 3. Only one among these is divisible by 3, that we have to show. Okay, or show that only one out of a plus 2 or a plus 4 is divisible by 3. So here only the variable has changed, the task is the same. So here we go with this. If n is any positive integer, using Euclid's lemma, n equal to bq plus r. If n is confusing, you can use a only. According to the below one, a only they have given, so you can write a also here. A equal to bq plus r. So this is given as divisible by 3. Okay, so divisible by 3. Look at the question. So we should write in terms of 3. So our b equal to 3. We should take our b as 3. N equal to bq plus r, and otherwise a equal to 3q plus r. How can this r be? The value of r can be either 0, 1 or 2. Okay, so r can be either 0, 1 or 2. So if you consider here, if r equal to 0, if r equal to 0, what is that? A equal to 3q plus 0, which is nothing but 3. This is a multiple of 3. So it is divisible. Okay, this is divisible by 3. Okay, if, okay, n plus 2 or a plus 2 let us take. A plus 2 is nothing but 3q plus 2. That is not divisible by 2 because here we have the remainder 2. When it is divided by 3, the remainder is 2. So this is not divisible. If it is a plus 4, a plus 4 is 3q plus 4. This is nothing but 3q plus 3 plus 1. Here 3q plus 3 is divisible by 3. But there is a remainder 1. So this is also not divisible. So only one number, that is 3q, is divisible. Okay, so if you come to the next case, if r equal to 1, let us take r equal to 1. So if a equal to 3q plus 1, here we have the remainder, so it is not divisible. If a plus 2, let us take a plus 2 equal to 3q plus 1 plus 2, that is 3q plus 3. Yeah, this is divisible by 3. You can write it as 3 into q plus 1. So this is divisible by 3. So this is divisible. Okay, let's go with the other one. A plus 4. A plus 4 is nothing but 3q plus 1 plus 4, which is 3q plus 5. 3q plus 5 you write, again split and write 3q plus 3 plus 2. Here you have the remainder 2. This you can write in terms of 3, but 2 you have. So this is not divisible. So here only one number is divisible, which is a plus 2. Okay, so this is for r equal to 1. This is for r equal to 0. Okay, now if you take r equal to 2, in that case what will you do? The same way. If r equal to 2, a equal to 3q plus 2. So 3q and your remainder is 2. It is not divisible. Now a plus 2 equal to 3q plus 2 plus 2. That is 3q plus 4. 3q plus 4, how will you write? 3q plus 3 plus 1. 3q plus 3 is divisible. You can write it as 3 into q plus 1. And again you have the remainder 1. So it is not divisible. If you write n plus 4 or a plus 4, that is 3q plus 2 plus 4. That is 3q plus 6. So here you can write in terms of 3. 3 into q plus 2. This is divisible by 3. So among these 3, 1 is divisible. Among these 3, only 1 is divisible. Among these 3, only 1 is divisible. So in all above 3 cases, we observe only one of either n or n plus 1 or n plus 4 is divisible by 3. Okay, therefore it is proved. So we conclude with exercise 1.1. See you again in the next video with the explanation for exercise 1.2. Please subscribe our channel for further updates. Put a like button if this video was really useful to you. Share with your friends. This will be useful for them to prepare for their public exams. Thank you.